National Institute of Standards and Technology, or NIST, also investigated the World Trade Center collapse.
Let me say about the NIST report. My paper and Kevin Ryan's paper addressed the NIST report, and those two papers are available at journalof911studies.com. NIST commissioned Underwriters Laboratories to do an actual experiment test with fire on floor assemblies. These are model floor assemblies now, built just like the World Trade Center floor assemblies. This is the right thing to do. Do an experiment. Underwriters Laboratories built the floor assemblies, put fire in there, more intense actually than what you would expect in the towers. They beefed up those fires. NIST, to their credit, says, yeah, that's right, the steel does not melt in these towers, but maybe warps enough. So we're looking at the warping here, see. And of course, in these experiments, where they had these extra hot fires for a long time, the steel did not melt, you see, at all. But what you do have is warping. So you've got these long floor assemblies, and the warping in the middle was about 3 inches, not that much, okay, 3 inches warping. But they didn't fail, see? They warped, yeah, 3 inches, but no failure. Kevin Ryan, he was working at Underwriters Laboratories at the time.
My name is Kevin Ryan, and currently technical services engineer for a healthcare company. I live in Indiana, and I was previously the division manager for Environmental Health Laboratories, a division of Underwriters Laboratories, also in Indiana. I have a degree in chemistry from Indiana University, and I have a certification in quality engineering, which is very closely related to standards in the National Institute of Standards and Technology. I was a laboratory manager at UL for years, so I know about testing samples from national standards. Primarily my involvement, though, is being given information, both verbally and in writing, about UL's involvement. Also seeing the importance of the issue, and then putting those two things into questions back to my upper management and what we were doing as a company to respond to the official story. But I think to some extent I was fooled by the official story as much as anyone, and I had to admit to myself at one point that I was wrong. That was in 2003. 2 years before that, right after 9/11, is when the chief executive officer of my company, Underwriters Laboratories, had told the staff that UL had tested the steel, had actually certified the steel, he said, used to build the World Trade Center towers. And found out that the steel evidence had been destroyed from the buildings. That related quite directly to the statements made by our chief executive officer that we had tested steel for fire resistance, and yet the steel had been destroyed, which the evidence would have told us what had actually happened. I first sent a formal question to our chief executive officer at Underwriters Laboratories in 2003, in late 2003, and I laid these concerns out to him. I said, look, you told us that we tested the steel or certified the steel. This steel has been destroyed. There's alternative explanations for what happened. You know, the official explanation is something that is, if true, extremely low in probability. So what are we doing? What are you doing to protect our reputation as a company? And he responded a month later. He did confirm that UL had tested the steel used in the World Trade Center buildings with quite a number of statements that I have in writing. Clearly, this chief executive officer, who was a Harvard-trained lawyer, by the way, not an engineer, had fully accepted the official story and had been given information himself about testing done 40 years ago by our company to certify the steel in the World Trade Center buildings. And he shared that both verbally and in writing with staff at UL. When he wrote to me, he copied several top executives who all have this in writing right now. And but he asked me to be patient, wait for the report from NIST, because UL was working closely with them to try and figure out what happened, and eventually there would be an explanation. And I did wait for another year, and the report came out. It included a great deal of contradictory information. They had done physical tests both at UL and at NIST, that showed that the steel could not have softened, the floors could not have collapsed. And yet the report was coming out suggesting these things actually did happen. So after a period of about a year, I made a presentation in Chicago where I spelled out the problems with this latest story, official story of collapse, because really the NIST report is one of a string of stories that have been given. Kind of a media story was given, Towering Inferno, a FEMA report was given, it was a pancake story, the Silverstein insurance claim was another story. NIST now has had a couple of stories, but this final story is summarized kind of in 7 steps. And if you walk through those and fairly summarize them and look at known facts about the buildings, look at the report within itself to see if it's self-consistent, just look at the story and see if it's realistic. In all 3 cases, you can see that it's not, that it's actually false at every one of those 7 steps. And that's just a collapse initiation sequence. They don't really describe the actual dynamics of the buildings falling. They actually just say, global collapse ensued. And that way they can ignore a whole lot of evidence that points to an alternative hypothesis, like explosions from witnessing explosions or hearing it, demolition squibs coming off the buildings, the speed of collapse, which is a very important piece of evidence. They can ignore all of that by just saying global collapse ensues, period. The biggest problems with that story are the fireproofing being lost, and I show in my lecture that the tests that were done, very weak and humble tests done by NIST, proved that actually the fireproofing could not have been lost in the buildings. There was no energy for it. There was no mechanism for it to occur. That's probably the biggest problem, is the idea that the external columns would bow inward, which is primary to the official story. There is absolutely no physical testing to support that. There is no intuitive reasoning behind it.
Furthermore, in their NIST report, as you read carefully, they only take you to the point where the towers are poised, each tower is poised to collapse. That's their term, poised to collapse. They don't look at what happens after it starts moving. So now then, what does NIST do? They go to a computer simulation, which is not as good as an experiment, you got to admit, right? Because this is now a computer model trying to get an explanation for the buildings to fail. When they got to the warping, instead of 3 inches, which is what the experiment showed, 42 inches, that's over 3 feet of warping. Now, that's a big difference. So you do the experiment, you get 3 inches, like that, and you do your computer model, and you stick in there 42 inches. I mean, what? You see what I'm saying?
And the only support is from a highly manipulated computer model in which, the temperatures were exaggerated, the fire times were exaggerated, all the fireproofing was stripped off, and the floors were disconnected, so that we've got absolutely no actual conceptual framework in which to see columns being pulled inwards. If the floors are disconnected, there's no force to pull the columns inward. How did it happen? We're talking about a phantom force now in a highly manipulated computer model. And that's what we're basing our future on, and all of these changes we're seeing. So they had test results that disproved what they were saying that happened. There were also comments being made still about jet fuel fires melting steel by experts supporting the official story. So I wrote to NIST and I asked them about their report, and I asked them to please clarify the ideas that are being stated in the media and in their report. And I was fired for writing the letter. I was fired for nothing else but writing this letter. I didn't violate any policies. I had been promoted just earlier that year to the top management position in my division. They gave me a letter of termination. They said that the relationship with NIST was harmed, that it was poor judgment. I was in the front page of my local newspaper, who also interviewed UL. And they asked UL, well, what this guy saying true? Did you test or certify the steel? And they said, well, there's no evidence that we tested the steel. They didn't say they didn't do it or their CEO was wrong. They said there was no evidence for it. Okay, that's a problem.
NIST is also under non-disclosure agreement. That's in their report. In other words, they can't say too much. So someone above them is putting these constraints on these guys. We offered to sit down with the guys at NIST or debate them, sit down, whatever, talk to them about our concerns. They declined. We had mentioned a specific time and place. And so we said, well, look, you name the time and place. We just think we ought to talk about these problems. I mean, this affects the whole world, really. The weaknesses in your analysis. And I guess I wasn't too surprised. They said a change in venue and a change in time will not change our decision. We're not going to sit down and talk.
I'm Jim Nesh. I've been in the foundry business for approximately 28 years. My expertise is I pour metal. I have a gas-fired furnace. It runs 750,000 BTUs, and I pour all non-ferrous metals, brass, bronze, aluminum. It takes me approximately, in a controlled environment inside the furnace, 45 to 55 minutes to melt brass, which is poured at 1950 to 2000 degrees. Bronze is higher temperature, but I can go to like 2350. I do not pour steel because it's too hot. Crematories are above, like, say 2500 degrees, that people are disintegrated. That if there were people in that building, how did they peek out and look or jump? How are they not melted immediately if they have a heat that intense to warp or mess with the structure of steel? How are the people still alive? It's impossible. To weaken something 50 feet away would have melted you to be in its vicinity. Logically, physically, no way could have caused a collapse in any way. It could not have affected the collapse of the World Trade Center. It's impossible.
After you let the buildings come down, you have to explain this flowing material right at the corner, by the way, which is on the north face of the South Tower. But right there at that corner, this molten metal with the orange glow, yellow-orange glow, flows out for minutes. There's a lot of it. And then right at that corner, you see this weakening, the twisting and the collapse of the building. NIST tries to explain that molten metal, which is yellow-orange color, a lot of material flowing out. They said, well, it's aluminum. That's what they said early on. And then I did experiments with aluminum and it's silvery. So they came back and said, well, aluminum with, wood, chips, plastic, carpet, stuff mixed in, that they said can have an orange glow. Well, the can caught my attention. I immediately was out doing experiments, Molten aluminum, we put in some wood chips and plastic, wood ash from my wood-burning stove, and carpet pieces and glass. I mean, we're just putting all this stuff in there. Melt this stuff up, and we have a young professor here who came from NIST. He couldn't believe that NIST would say, if you mix organics with aluminum and pour it out, now it'll have an orange glow. He couldn't believe they'd be wrong, but we couldn't get it. So he was working with me for over an hour, mixing this concoction of molten aluminum with wood, glass, plastic, carpet pieces, mix, and it doesn't want to mix, that is, the organics don't want to mix with the molten aluminum. We just poured it out. He poured it out, actually. Silvery, not orange glow, no orange glow.
I melt aluminum. Aluminum is white colored, silver colored. There is no different colors in it. That's the only color it can be because it's silver colored. To have a different color in there means another chemical has to be involved. There was no melting of any structures below whatever story it was on down. So if something fell, it's going to just land there and stay there. The building's not going to fall down.
On July 28, 1945, the Empire State Building was struck by a B-52 bomber on its way to Newark Airport. It left a hole 18 feet wide and 20 feet high, but the building did not collapse. It was for this reason that the World Trade Towers were built to sustain impacts from several jet airliners.
The building was designed to have a fully loaded 707 crash into it. That was the largest plane at the time. I believe that the building probably could sustain multiple impacts of jetliners because this structure is like the mosquito netting on your screen door, this intense grid, and the jet plane is just a pencil puncturing that screen netting. It really does nothing to the screen netting.
Frank A. DiMartini died in the 9/11 attacks. Lee Robertson, the WTC project structural engineer, also confirmed that the towers were designed to take hits from jet aircraft.
Well, the columns and core this was a self-standing core. It was the first thing that went up, and the rest of the building was built around it. 47, these are huge columns, 47 of them, and they held the elevator shafts and some service floors and so forth. This was regular construction grade steel, A36 it's called, which means it has 36,000 psi of yield strength or greater. And so it's typical construction steel, but it's very huge columns. Around the outside of the building were 236 columns that were box columns made of very high grade steel, like 65,000 psi steel.
Let's take a look now then at these 14 floors above the damage where the plane came in as a block in the North Tower. And let's do two things. Let's have a giant crane and imagine that picks up 14 floors and just drops them in air. You know, no building below, just drop them in air. How long will it take for the roof to get to the ground when you do that? Well, it works out to just about 9 or 10 seconds. There's some air resistance, but pretty much ignore that. The height of the North Tower, 1,368 feet. If you dropped a steel ball in vacuum, it would drop in 9.2 seconds. So we got this big block. We're doing the same thing, except we're dropping it in air. And, 9 or 10 seconds is what you'd expect. Now, how long did it actually take the building to collapse? Well, it's about 10 seconds, maybe 12. It's a little hard to tell now because there's so much dust. But if you look at the seismic record, when the shaking started, as that building started coming down, when it ends, just about 10 seconds. Okay, now we've done that one experiment. We drop it in air, 10 seconds. Now you take the same block and you drop it over the rest of the tower that's still there. You've got 47 core columns below, 240, these are steel columns going up the center of that thing, huge. At the base they're 4 foot by 2 foot, steel, okay. Interconnected columns, designed to stay standing, not to just give up, when something hits them. And then you've got 240 perimeter columns. Now you drop that block of 14 stories, okay, above the damage zone. You don't that drop on the rest of the building. What happens? Well, which is going to take longer? The one you drop in air or the one you drop on, a couple 100,000 tons of steel and concrete that's designed to remain standing? Which is going to take longer? The one that you drop on the building obviously should take a lot longer than the one you just drop in air. The situation, when you time it, it's essentially free fall speed. Goodness, how does that happen with all this steel in the way? This is another way of saying that we need to look at conservation of energy and momentum. That analysis has been done by Professor Cutler, professor of mathematics. He comes up with 36 to 40 seconds, just this block hitting stationary matter. And now you throw in the columns, and this gets us to Gordon Ross, a mechanical engineer in the United Kingdom. He says you put in the columns and conservation of energy and conservation of momentum. None of those looked at by FEMA and NIST, you see this. His final result is that the upper block will stop. The destruction goes a ways, but then it stops. I mean, why should we assume that the building below just gives up? No. That upper block goes a ways and then it stops. And it might actually fall off due to asymmetry. That's what you expect. You don't expect it to fall straight down at free fall, near free fall speed, unless you get the material out of the way below. The way that's done is with explosives.